Hello, calculus fans. All right, we're going to drop a ball from the top of the Washington Monument in D.C. The top of that monument is 170 meters above ground. What we'd like to do is find the average velocity of the ball on the time interval between t equals 2 and t equals 2.4 seconds. So we're just going to see during that brief instant between those two time intervals, what's the average velocity. Now the distance that an object falls when it's dropped is 1/2 g times t squared. This is a formula from physics, and you don't necessarily need to memorize this formula, but it's sort of good to know. It's going to come up fairly often. G is the acceleration due to gravity, and t is how long we let the object fall. We'll be able to do some more calculations later on to see why this is true. Now on Earth, we're all on Earth, the acceleration due to gravity is about 9.8 meters per second squared. So that tells us that the distance an object falls is given by the formula s of t equals 4.9 t squared. So if you drop an object, this tells you how far it will fall in t seconds. Now average velocity is computed using v equals delta s over delta t. That's distance traveled over time elapsed. We're going to use the Greek letter delta to denote change. Something is changing. So delta s means a change in position, which is a distance traveled. Delta t is a change in time. That's time elapsed. Now the time elapsed in this situation is delta t equals 2.4 minus 2, which is 0.4. Now we need to figure out what the distance traveled is. So the distance traveled is delta s, and that's s of 2.4 minus s of 2. So if we plug that into our formula for s, we get 4.9 times 2.4 squared minus 4.9 times 2 squared. And that all works out to 8.624. So now we can say what our average velocity is. Our average velocity is delta s over delta t, and that's 8.624 divided by 0.4. And that works out to 21.56 meters per second. So that's our average velocity. Okay, that's all for now.